Okay, so for the new chapters, okay, on line integral. Okay, so if we recap back, okay, on the integral that we have learned so far. Okay, so in the previous syllabus, okay, you learn on single integral over straight line. Means that it's going to be a normal integral, okay, that will be integrated, okay, for example, from A to B. Okay, but then when we move to engineering mathematics 2, okay, you learn on double and triple integral. Okay, so now, okay, we're gonna learn on line integral. Okay, so it's another type of integral. Okay, so it's actually a single integral, okay, over a curve in three-dimensional space. Okay, so you must remember that when we talk about line integral, okay, so it's integrated, okay, integrate over a curve instead of integrating over an interval like we had learned previously. Okay, so there is so many applications that can be related to line integral. So this is several application that can be used that can be solved using line integral. Okay, so that's technically the difference between what we had learned and what we will learn in this chapter. Okay, so for the first component is line integral of a scalar field. Okay, so when we take a look on this one, okay, so suppose we have a scalar field. Okay, so this scalar field is continuous over a smooth curve. Okay, because like I said, okay, so it's gonna be a single integral over a curve, right? So we're gonna need a curve. Okay, and then we have S is the arc length measured along C. Okay, so in another way, okay, you need the equation of the curve in order for you to solve for the line integral. Okay, so the equation of the curve, okay, is given in term of this one. Okay, either is given, okay, or not, okay, you need the equation of the curve in order for you to solve for line integral. Okay, if the equation of the curve is not given, you must figure out it. Okay, so if you notice that, okay, so this one is in parametric equation. Okay, so this is the what I'm supposed to say, the line integral of scalar field. Okay, so we have ds over here. Okay, because now we would like to integrate, okay, over a smooth curve, right? Okay, so from here, okay, we're going to transform in this way in order for us to integrate. Okay, so now we're going to integrate respect to t over here. Okay, where ds now is equal to this part. Okay, or it can be changed to this one. Okay, so this one, okay, the term that we need to change, okay, in order for us to replace this, the s over here is coming from the equation of the curve. Okay, so we will see, okay, we will see on how can we solve the line integral for scalar field. So this one is scalar field, right? So this one is given. Okay, so let's recall. Okay, so you might need this one. Okay, you might need this one, okay, in order for you to get for the equation of a curve. Okay, so I put it here actually. So this one you have learned, okay, you have learned in the previous subject. Okay, so I just put it over here so that you can refer. Okay, I will also show one step, okay, on how can you use this one. Okay, so let's take a look. Okay, so let's take a look if we have pattern of the question like this. Okay, so the question asks you to evaluate the line integral. So this is the given question along a curve over here. Okay, but then this question forgot something. Okay, so they're supposed to give, okay, the limit for t. So let's say if we take, okay, let's say if we take this like this, because we would like to integrate, right? For example, let's take a look back over here. Okay, so this one is gonna be a definite integral. Okay, so you're supposed to get, you're supposed to have the range for t, because now instead of ds we have changed to dt, right? Okay, so you need to have the limit for t. Okay, so if we add this one, okay, if we add this one, okay, because this one should be given together with this one. Okay, so let's take a look on how can we solve this one. Okay, so we have like this. We have like this. Okay, so we have x z square ds over here. And then we have the equation of the curve, right? Okay, so the equation of the curve is t squared t 4 over 3 2 over 2 over here. So this is the component of the equation of the curve. Okay, so from here, okay, from here, we know that xt is equal to t squared, yt is equal to t, zt is equal to 4 over 3 2 over 2 over here. Okay, so we need to find the derivative, right, respect to each equation over here. So we're gonna get that. Okay, so x prime is equal to 2t, y prime is equal to 1, and then z prime is equal to 2t to the power of 1 over 2 over here. Okay, so why we need this one? Okay, in order for us to transform this part, right? This part. Okay, so now we have that ds is equal to, okay, this one, right? So we have 2t squared plus 1 squared plus 2t half over here squared. And then don't forget dt over here. You need this dt, right, in order for you to transform this one in dt. If not, you will not be able to solve that line integral. So if you expand, you're going to get like this. It's going to be 4t squared plus 4t plus 1 dt like this. Okay, so this one can also be simplified. Okay, so this one can also be simplified like this. We have 2t plus 1 squared dt. So from there, you can cancel out the third. So we're going to have 2t plus 1 dt over here. Okay, so sometimes you need to, for this part, okay, you need to try to simplify, okay, as simple as that, so that will be easy for you to solve the integral. Okay, so we have this in this form. So now ds is equal to this part. Okay, so from here, we're gonna put into the original one. So we have z squared ds, right? Okay, x just now, okay, if we recall back, so x equal to t squared, right? And z is equal to this one. Okay, so we're gonna put it like this. Okay, so the limit for t is given, right? 0 up to 1. I forgot to add here. Okay, so we have x. Okay, x is equal to t squared. Z squared is equal to this part, right? So it's going to be multiplied with 4 over 3 t 3 over 2 squared. And then ds is this one that we have been transformed. It's going to 2t plus 1 dt over here. Okay, so if you if you simplify this part, okay, so you're going to get that is going to be 16 over 9 over here, 0 up to 1. It's going to be 2t to the power of 6 plus t to the power of 5 over here, dt. So if you take a look on this one, so this one is going to be a normal integral, okay, a normal integral that have been simplified, okay, that have been transformed. Okay, so up to here, I think it should be no problem to solve for this one because it's just a normal integration. So we got like this, right? 0 up to 1. So you're going to get that the answers would be 152 over 189 over here. Okay, so that's how you solve. Okay, so based on the first one, okay, they give you the equation of the curve. Okay, and then the limit for t is given. Okay, in certain cases, okay, for example, like B. Okay, like B, they just ask you to evaluate the line integral. Okay, where C is the line segment from this point to this point. Okay, so if you take a look on that question, okay, you're gonna solve the same way as what you solve in A. but you need to figure out the equation of the curve as well as the limit for t first, so that you will be able to solve the line integral. Okay, so let's take a look on B. Okay, so let's take a look on B over here. Okay, so this is where you need to apply this part, the parameter equation for a line. Okay, so obviously that, okay, if we talk about line segment, right? Okay, so we can actually you know, try to, I'm supposed to say, if we can actually say is this way. So let's put it point over here, 1 2 3 for example, and then we have another point 0 negative 1 1. Okay, so it's gonna be a line segment like this. Okay, so this is where you apply the way you what I'm supposed to say, to get the equation of the curve or the line. Okay, so from here, okay, so from here, wait, so this is gonna be x naught, y naught, and z naught, right? Okay, so from here, okay, so from here we're gonna use this one. Okay, so it's gonna be, let's figure out the equation of the curve first. Okay, so the line segment from this point to this point. Okay, so we're gonna get that x is equal to, okay, so x naught is 1, right? So x naught is 1. Okay, plus with 0 minus 1 over here, and then we have t. So we're gonna get that 1 minus 1 minus t over here. Okay, then for y over here is gonna be the y naught is 2 plus, over here is negative 1 minus 2t over here. So it's gonna be 2 minus 3t, and then z is equal to 3 plus 1 minus 3t. So it's gonna be 3 minus 2t over here. Okay, so it's similar to what we had like this, right? Okay, so now we got the component, right? Okay, so we have x equal to 1 minus t. So we must find the derivative. So x prime is equal to negative 1. Y is equal to 2 minus 3t. So y prime is equal to negative 3. And z is equal to 3 minus 2t. Where z prime is equal to negative 2 over here. Okay, so from here, obviously that the s that we will figure out is going to be just a number, right? So it's going to be negative 1 squared plus negative 3 squared plus negative 2 squared dt. So if you simplify, you're going to get square root 14 dt. Okay, so in this case, it's just a number. So you don't need to simplify for these cases. Okay, so we have figured out ds over here. Okay, so now to get the limit for t. Okay, so we have the what I'm supposed to say, okay, yeah, like this. Okay, so like this. Okay, so we have, for example, if we take the point x naught, our x naught is 1, right? Coming out from this one, where we can say that x1 is equal to 0, because the line segment is from here to here, right? Okay, so this is the information. Okay, so we have, okay, for example, okay, from the equation, so the original equation is x equal to 1 minus t, right? Okay, so if we take x naught equal to 1 minus t naught, right? Because we like to find the limit for t now. Okay, so our x naught is equal to 1, right? So 1 minus t naught. Okay, so from here you're gonna get that t naught is equal to 0 over here. Okay, so same goes to when we try to find x1. So over here is gonna be replaced with x1 equal to 1 minus t1. So x1 now is 0. So 1 minus t1. So from here you're gonna get that t1 is equal to 1. Do not just instantly, okay, use this limit, which is 1 to 0. Because the limit should be for t, right? It's not for x. Okay, so now from here, you got that the limit for t is supposed to be between 0 up to 1. Okay, so you must check, okay? You must check for this one. Okay, unless it's given. Okay, so we got the limit for t, okay? We have the values of ds, okay? And then we're gonna solve the line integral. So the question just now is x plus y plus z ds, right? So if we transform 0 up to 1, our x just now is equal to 1 minus t, right? Plus, okay, our y is 2 minus 3t plus z is 3 minus 2t. And then ds just now is square root 14 dt, right? Okay, so if we try to simplify this one, so you're going to get a 0 up to 1 over here. And it's going to be, let's put square root 14 outside. Okay, and then over here, if you simplify, you're going to get is going to be 6 minus 60 dt. Okay, so if you solve this integral, you're going to get that the final answer would be 3 square root 14. Okay, so that is the way, okay, the way you solve for different kind of question, but still asking you to solve for the line integral. Okay, so I would like you to try by your own, okay, on how can you solve for C. Okay, so the pattern of question actually is little bit similar, okay, to B. Okay, but you must figure out now how can you solve for C. Okay, so there's one more the pattern of the question. For example, if they give you like this, okay, where C is the curve, okay, given by this one, for t is between 0 up to pi over 2. How can we solve for this one? Okay, so we're going to take a look over here. Okay, so they give you the line integral in this way. Okay, and then if we try to extract the information, so we know that RT is equal to, okay, t squared negative 2 and then sine t over here, where t is between 0 up to pi over 2. Okay, so from here, we're going to get that xt is equal to t squared, yt is equal to negative 2, and then zt is equal to sine t, right? Okay, so from here, okay, if we differentiate, if we differentiate respect to t, so we're going to get dx over dt is equal to 2t, right? Okay, so if we make an arrangement, so we're going to get that dx equal to 2t dt, right? Because in the original question, we have dx, dy, and dz, right? So we're going to replace dx, dy, and dz coming up from this one. Okay, because previously they give you in ds, okay, so you have to transform that one, but in this case they give you in dx, dy, and dz, so you must transform it to be in this way. So we have dx over here, so from here, from this one, y, okay, so you're gonna get that dy is gonna be 0, dy dt equal to 0. So if you rearrange, you got dy equal to 0. For this one, if you transform it, okay, you're gonna get that dz over dt is cos t, right? So over here, dz is equal to cos t dt. Okay, so we got this one coming out from the equation of the curve. Okay, so we're gonna replace all the terms over here. So now it's gonna be from 0 up to pi over 2 in this case. Okay, so our x, so let me split up this one. Okay, So x squared. So x squared gonna be replaced with this one, right? So it's gonna be t squared square. And then dx over here. So dx should be coming out from this one. So it's gonna be 2t dt plus, okay, so this one is gonna be plus, wait, minus, right? Sorry, this one should be minus, right? Minus sine x. So t squared over here. And then dy is equal to 0. So just, you know, just this term gonna be cancelled out. And the last one is gonna be 2y. Y if negative 2. And then z is sine t. And then dz is equal to this one, cos t dt. Okay, so if we, what I'm supposed to say, if we rearrange the terms, so you're gonna get like this 0 up to pi over 2. So it's gonna be 2t to the power of 5 over here minus 4 sine t cos t over here dt. Okay, so up to here. So now it's possible to integrate, right? Okay, so if you integrate this one, you're gonna get that the final answer would be pi over 6 over 3 to the power of 6 minus 2 for this one. Or if you just transform it, okay, so it might be in this way, pi over 6 and 1 over 2 minus 2. So this one also possible. Okay, so the way you integrate it, okay, based on what you have learned so far. Okay, but the first thing first is how can you, you know, from the given line integral, how you're supposed to transform in order for you to solve it. Okay, so I have explained so far, okay, for 3 pattern of question, I would say. Okay, so there is one more question that you would like to solve it by your own. Okay, and then we'll discuss during live session. Thank you.